Hey, Algebra 1, this is page 2 of the Unit 2 review. Okay, let's get started. Okay, so answer the questions below using the following graphs. Okay, so which graph is not a function? Okay, so for each of these, this is where we want to use that vertical line test. Okay, for any time you have a graph. So I'm going to take my vertical line, and I'm going to go across each one. And the question is, which ones are not a function? Okay, so as I go across this graph, boom, right there, right away, I'm hitting not just 2 points, I'm hitting 1, 2, 3 points. So this one is a no. Okay, so we'll put A here because it is not a function. Okay, do another line. Okay, so now as I go across this function, do I hit more than 1 point as I go across? Nope, I don't. So that B is a function, so I will not list it here because we're looking for ones that are not a function. Okay, and then C, as I go across this one, again, it does not touch more than 1 point, so that is a function. So I won't list that there. And then the last one, D, as I go across D, boom, right there, you've got this part of the graph where it goes straight up and down. It's like I'm touching a ton of different parts here on this line. So as I go across the middle part of this graph, I'm okay. But then on the outsides, there's these two parts that go straight up and down. So because I'm hitting this graph here and here and here and here and here and here and here, it's not a function. So D. Okay, and I'll say A, D using the vertical line. Oops, sorry about that. Vertical line test. Okay, which graphs have a domain of all real numbers? And what we're saying in Mr. Osborne's class is which one has a domain that is infinite in all directions. In other words, the domain is negative infinity to the left and positive infinity to the right. Well, we know that it's going to be negative infinity to the left and the right as long as there are arrows continuing off to the left and continuing off to the right. Okay, so bring it down a little bit. Okay, so we know A for sure because to the left, it's got an arrow going in the left direction and an arrow going in the right direction. So the A does have a domain infinite in both directions. Okay. B, it does. It's a little harder to see because it looks like this arrow is going straight down, but it's going down at an angle and it's going off forever to the left, even though it's going really slowly to the left. And then also doing the same thing to the right. So going off to the right at a really slow pace. Okay, so that one is also infinite in all directions, or negative infinity and positive infinity to the left and right. C is the same thing, infinity to the left and to the right. And D, as you can see, it is a shape, and I just now noticed, is a shape that has a line here at the bottom as well. So if going back to the vertical line test, it's actually hitting right here and here. Okay, and it has no arrows going to the left or right, so that is not a graph that has domain in all an infinite domain in all directions. Okay, so now find f of 4 for graph A. So I'm going to need to find the output of 4 for graph A. So in other words, I have the x value, I need to find the y. So I'm going to go to the graph, I'm going to find the x value of 4. Okay, so I go to the right, 1, 2, 3, 4, and then I go up to the graph. And right there is that point. And the y value at that point is, counting up from the middle, 1, 2, 3, 4, 5. So the output is 5. Okay. Now the next one, I'm given the output, so I need to find the input. So I'm not going to start on the x-axis, I'm going to start on the y-axis. Okay, and we're looking for graph B in this case. Okay, so I'm going to start on graph B and go up to positive 1. Now what I need to do from there is go to the graph, either left or right. And I go to the right to get to the graph. And it's right there. That's where it touches the graph. And if I count out the x-axis, that'll give me the input. 1, 2, 3. And right there, so the input is 3. In other words, the point here is 3 and positive 1. What is the y-intercept of graph C? Where does this cross the y-axis? Okay, and remember, with y-intercept and x-intercept, for the next question, we want to know the point. Okay, so for the y-intercept, I go up to graph C. Let me zoom in a little bit. Where does it cross the y-axis? Okay, here's our x-axis, here's the y. Okay, so it looks like it crosses here, and that's 1, 2. So it crosses at the y value of 2. So if I go back down here, for y-intercept, y value is 2, and then x is always 0. Okay, now for x-intercept for graph A. Where does it cross the x-axis? Here's our x-axis, here's our y. And it looks like the line crosses right here at negative 1. Okay, so the x value is negative 1 because it crosses x at negative 1, and so that makes the y 0. Next one, what is the minimum value of graph, or what is the lowest value of the graph? And remember, when we talk about the minimum and the maximum, we're only talking about the y value. Okay, so minimum of graph D. Okay, well, it looks like the lowest point, get some of this stuff out the way here. Looks like the lowest point of this graph is along this line here at the bottom, and that's at the y value of 0. So the lowest value for D is 0. In the same graph, what is the maximum value? What's the highest point? Well, the highest point is up here, and the y value there is 1, 2, 3, 4, 5. So y equals 5. So I can simply here just put 5. Okay, so number 9 and number 10. Well, what I want to do here, so get both in the picture here, is I want to recognize the pattern first, then I need to find the next number. Okay, so what I need to do, the first thing I want to check is see, is it adding and subtracting something? So what I do is I take the next number in line, and I subtract it from the previous one, so 25 minus 32. Now you could do this in a calculator, you could do it in your head, but just remember these two signs have different sign, or sorry, two numbers have different signs, so we subtract 30 minus 25, which is 7, and negative 32 is bigger, so it's going to be negative 7. So that means the pattern is minus 7, but we want to check, does that true for the next one? 18 minus 25, do you get the same thing? And yes, it is negative 7, so that must be the pattern is minus 7 every time. So then I go to the last number, 11 minus 7 is 4, so that's the next number. Okay, so now the next one, I want to do the same thing. First check, is there a pattern if I just subtract? Okay, so I'll do 6 minus negative 2. Okay, so these negatives will cancel, will become positive. We have two signs. We're going to do change, change. So 6 plus 2 is 8. But we don't want to stop there. We want to check, do these other two numbers have the same pattern? And right away, I'm already recognizing, okay, those numbers are pretty far apart. I don't think that that's going to give us the same result. Okay, oops, that's not positive. I'm sorry, that's not negative 54. And already right away, I noticed that negative 162 minus 54, that's going to be nowhere near plus 8. So if it's not adding or subtracting, then that means we must be multiplying or dividing. Well, I know it's getting bigger, so it has to be multiplication. Okay, so the next thing I want to try is I still go to the next number, and I divide it by the number before. So it's 6 divided by -2 is -3. Okay, so now I want to do that with the next one. So -162, the next number, divided by the number before, divided by 54. Well, that's going to give us -3. So what that means is that we're multiplying 3. Okay, now we're looking for the number in the middle of this pattern, not at the end. So we want to basically do, it's -3. So we want to take this 6 and multiply it by -3. So multiply -3 and we get -18. So I'll write my answer here, -18. Okay, that was page 2. Go to the next video for page 3.